Good morning, everybody. Welcome to day 2, water stream at the EOCP conference. Pleased to introduce Jeff Phillips. Jeff has worked in the waterworks industry since graduating from Applied Science at the University of BC over 25 years ago. So Jeff has a lot of experience, and judging by all the gizmos up here on the platform with me, we're in for a good talk. Jeff has worked as a consultant, product engineer for pipe and fitting manufacturers and fabrication companies. He's also worked with industry associations and involved in writing standards, bylaws, technical manuals, and handbooks. So please help me in welcoming Jeff to the podium. Thanks, Jeff.
Thank you. Okay, so you're going to be stuck with me for 2 presentations in a row. The first one is on joint restraints and similarities and differences between the two. There we go. Now the presentation's up there, so perfect. So feel free to ask questions as we go. I'd say to an audience if they're here, but type them in and they'll probably get thrown to me as we go. Last year we had me and our sales guy, Craig Sloan. He was here. Unfortunately this year, COVID's lightened up a little bit, so he's out doing his job somewhere else in BC. I don't even know where he is today, but so it's just me. So what we're going to talk about is ductile iron joint restraints, PVC joint restraints, and ones that can be used for both. And I'm going to show you how they work and the similarities, differences, why one can be used for one and not for the other. I'm going to keep it generic. Pictures are obviously going to be Star. That's the company I work for right now. But this is generic across the industry. Everyone's restraints work fairly similar to one another's. So this is an example of a wedge action restraint. I'm going to talk about wedge action first and then move into the serrated restraints. And this is a ductile, but its principle of how it operates is the same as a PVC. So it's a quick little video here. I'll see if I can keep looking this way while pointing over that way. So on the video you can see the pipe's already inserted, well, a little shaky, into the joint. T-bolts are put in, tightened up properly. We go to a cutaway. Now in the cutaway you can see the wedge. So the first thing that happens is you tighten the wedge bolt, it engages in the pipe. And then you tighten the wedge bolt a little bit more, and the torque off nut breaks off, and that's how you know you're at the right torque for the restraint. Then you pressurize the pipe. This is when the restraint is fully engaged. So when you pressurize it, you can see right here that it moves down this inclined slope, and that's what pushes those wedges into the pipe, whether it's a PVC or ductile. And once it's pressurized and that thrust force has pushed that fitting away, that's when your restraint is actually fully engaged. Before then, it's just set up, but it's not engaged and operational yet. Or not operational, but so now I'll get into the ductile iron part of it. So the ductile iron wedge action restraints, industry standard, they're black. If it's not a black one, it's probably not for cast iron OD ductile iron pipe. Gray ones would be for an IPS-sized ductile pipe. No, sorry, that's for the serrated ones. So black is for ductile. Here is, I don't have the real one with me, so bear with me. I've just got 3D printed versions of other stuff along here. So this is what a wedge action ductile iron restraint looks like. The wedges are fairly small. This is a 4-inch one. I'm going to use 4-inch so I can compare between all 3 different models. And this is a wedge for a ductile iron restraint. You can see the wedge has fairly sharp teeth because a ductile iron pipe is hard. You need the sharp teeth so you can bite into that hard surface and get a grip and restrain it when it's needed to be restrained. And you don't need that many around them. 4-inch only has 2 restraints on it. Most common application for wedge action ductile restraints are going from a ductile pipe, I don't know, it's steel pipe I'll talk about in a second, but it's going from a ductile pipe to a MJ fitting. On the back of the restraint, I've got a PVC one here, but you can see there's a gland right here. That's what compresses that MJ gasket in there. So ductile one is the same. So yeah, this is 90% of the market uses MJ fittings as opposed to push-on fittings. So this is where most of the wedge action ones go. If you're going on to steel pipe, you'll need to use a transition gasket as well. What the transition gasket does, at 4 inches, all I had sitting around the garage, but this one's a transition gasket. This one's a standard gasket. You probably can't see. I'll zoom in, but it's not really working. This one's a little thicker. Don't worry about it. The OD of a steel pipe is smaller than the OD of a ductile iron pipe. So you need the transition gasket so you can compensate for that OD differential. Same principle, tighten the wedges, engage it, it goes. If you're using a plain end MJ fitting, what restraint do you use on it? Our recommendation, and recommendation of pretty much every joint restraint manufacturer in the industry, is you don't use any. This is the one application I would suggest you probably use a thrust block. The reason we don't recommend joint restraints for plain end ductile iron fittings is they're manufactured in a different method than ductile iron pipe. Ductile iron pipe's made by pouring your molten iron into a centrifugal mold, and then after the pipe's made there, it goes into an annealing oven. That annealing oven sets the hardness, tensile strength, all the properties of that pipe, fairly tightly controlled, so you know what your properties of that pipe are going to be. A fitting, when it's made, and the next presentation I do coming up after this one shows how fittings are made, it goes into a sand mold. So the molten iron's poured into a sand mold, and when it's poured in there, it cools off in there, and the properties are set in the sand mold. There's not near the same control over what those properties are going to be. We know the minimums they're going to be. We can control that, but they might exceed that to a higher degree. So the hardness of this fitting could be harder than the pipe. The problem that comes to is your restraint wedges are designed to bite into ductile iron pipe and the hardness of that pipe. If the MJ fitting plain end is harder than that, the wedges may not bite into it, so you won't get any restraining done there. Do people use it in the industry? Yeah, it's used out in the industry all the time. People put restraints on it. But everybody's literature will say somewhere in the writing, in a footnote, in a note below pressure ratings or something, it will say don't use on plain end fittings. Another common use for this is pipe to pipe. So you can use a wedge action restraint. We call ours a 3100, but it's just a pipe to pipe restraint. How that works is you have these are my 3D printed lovely things. Come over here, you can probably see it better. You've got your restraint. You got your pipe here. So the restraint with the wedges goes on one side, put it into the bell of the pipe. On the other side, I'll grab that after, thanks. You have your handy dandy restraining gland, put them together, and then you rod between the two. This one doesn't have wedges on it. It just sits behind the bell of the pipe and it holds on there. The pipe side will have the wedges on it. If you are doing you need to put it on a pipe that's already installed in the ground, you can get a split version, so the two halves will come together, so you don't have to slide it over like I did there. You can put it on existing pipes in two halves. If you need to get higher pressure ratings, you can use what's called a tandem restraint. So it's two wedge action restraints back to back into an MJ fitting. This is most common on 18 to 24 inch, where the fitting is rated to 350 PSI and the restraint's only rated to 250 PSI. In order to get that rating up to 350 PSI, you need to do it in tandem. When you do it though, you have to be careful, because now your T-bolts, hopefully you can see where I'm pointing here, your T-bolts here are a lot longer. So you need to first put this first restraint on, put your nuts on the T-bolt, thread them all the way down, and tighten those up. And you need to torque those to the proper torque, and it depends on the diameter of the pipe what that torque is. You cannot get a deep socket on there to do the torque settings, so you can use what's called a crowfoot. wrench and put that on your torque wrench. That'll go around the pipe and you can tighten it. That's what it looks like. There's other applications for this for fittings where you can't get it into. They're really good, and it allows you to get your proper torque with your torque wrench. Otherwise, you just have worker out there on the field going by feel, and that's how you get leaks. You want to use the right tools. You have to use torque wrenches to tighten up your T-bolts on MJ. You don't have to, but it's highly recommended. Cast iron pipe, pit cast. If you're going to install an old pit cast pipe, you can't use a standard ductile iron pipe restraint. The reason is pit cast pipe has a larger OD, so you need to compensate for that larger OD. How you do that is most manufacturers will have an oversized restraint that will slide over your pit cast and go on. When you're putting it on this pipe, though, you have to make sure the pipe is in good condition and not corroded. The biggest concern is if there's graphitization, and what that does is you can't really see it. It is a type of corrosion, but you can't necessarily see it. The pipe will still hold pressure. So your water, you wouldn't know it was bad pipe. But if you hit it with a shovel or a backhoe, that pipe could easily break. So the same happens if you somehow don't break it when you're digging up. You get the oversized restraint on there, you put it on, and then there's a thrust force. That thrust force kicks in, those wedges grab, it can shatter the pipe. It can crack the pipe right there. So you have to make sure that that pipe is in good condition, and get someone out there who knows how to do that. I'm no expert on that part. There's also wedge action restraints that will help you convert to it would look like this, or what's on the picture there, to a flanged fitting. So if you have a flange coming off, you got a plain end piece of ductile iron pipe, there are these methods to connect them together. PVC restraints, wedge action. I'm not going to show this video because it's exactly the same as the video I showed before. Wedge goes down the inclined plane, it reacts with the pipe. So you saw that 2 minutes ago, more like 6 minutes ago, so you don't need to see that again. For PVC pipe, most common application for these, again, is going into a ductile MJ fitting. When you're going into the MJ fitting, again, make sure your T-bolts are done up to the proper torque. If you're going onto a PVCO pipe, there's a couple manufacturers who make it. IPEX makes Bionics, JM makes whatever they call their PVCO. I can't think of the name of it right now. The T-bolt torques on those are reduced. I've only seen one manufacturer doesn't recommend reducing them. Us and every other manufacturer except one says to reduce the T-bolt torque on a PVCO pipe. The reason is that the pipe is a lot more compressible, so as you tighten those T-bolts, you will start pushing that gasket into the pipe more, and it'll just kind of make the pipe into a hourglass kind of shape. So reduce it. 75 to 90 foot-pounds standard PVC. Ours is 55 to 65 foot-pounds for a PVCO. But depending whose restraint you're using, you want to check with the manufacturer what their recommendations are if you are using PVCO pipe. And next slide. There we go. So here is a picture of the PVC restraint. You can see it's red in color. Red wedge action restraints are for PVC. Black wedge action restraints are for ductile iron. Difference between it mainly is in the wedge. You can see the wedges are a lot larger on a PVC restraint, and the teeth on it are not nearly as aggressive. They're a lot less sharp, a lot smaller teeth. And as I said, the wedge takes up the majority of the restraint. This is a 4-inch PVC one, so compared to the 4-inch for the ductile. Another application, you can use it on IPS or series PVC pipe, which has a steel pipe OD. So again, because the OD is smaller, and this is up to 12 inch, you can add your transition gasket, put it in the MJ fitting, but on a PVC restraint, you will also need to remove the washer. And what that washer is, I've got one right here as well. It's right here. Some are plastic. This one you would just use a pair of pliers and snap it out like that. This is exactly what's shown on the slide there. Other ones, depending on manufacturer, or if it's an older one of ours, could have used a steel washer. To remove this washer, you need to actually remove that wedge bolt. Once the wedge bolt is removed, slide the washer off, put it back on. The reason is that washer prevents the wedges from engaging too far into a PVC C900 pipe. On an IPS pipe, you need those wedges to go in further. If you don't remove that washer, wedges won't engage the pipe. They may not even engage the pipe at all. But if they do touch the pipe, they're not touching the pipe enough to get the reaction on the pipe to restrain it. So that's a very important thing to make sure you remove that. And make sure it's not removed for C900 pipe. Up to 12 inch. Above 12 inch, we don't recommend it be used on IPS or series pipe. And forgot to mention, for the ductile iron ones, can be used on steel pipe up to about 12 inch, Schedule 40, Schedule 80. Above 12 inch, call the joint restraint manufacturer. It can be used on steel pipe above 12 inch if it's cast iron OD steel pipe. Wall thickness is thick enough as well. So each manufacturer will have slightly different recommendations, so it depends whose you're using. If you're using ours, give me a call. If you're using someone else's, give their technical person a call. They'll tell you what you can do. For pipe to pipe, it's like pipe to pipe on the ductile iron. It's a wedge action restraint on one side, and it would be red, and restraining gland on the other side that just slides behind the bell and holds it in place there. It's very common use here too. For larger size, it's actually, you need to use what's called a 4400 for us, but other people call it different names. And what it is, when you get to the larger size PVC, you can't just use your standard PVC restraint with a backup ring on the other side, because these bolt holes, there we are, now we're in frame. These bolt holes may not be high enough to clear the bell on a larger diameter PVC with a thicker wall. So if it's a DR14 24 inch, that bolt hole may not be out far enough to clear over the bell. Every manufacturer makes their bells different for PVC pipe. There is no standard that says how to make your bell. So what we and other manufacturers have done is we've made our pipe to pipe for the larger diameter have larger holes for the rods to go through to make sure we clear that thickest bell on that diameter of pipe. And again, you can go a flange restraint as well, connect to a flange, restrained. Then we also have, and don't have it here, but there are wedge action restraints that can work on both ductile iron pipe and PVC pipe. Again, most common application for it is going into an MJ fitting. These fittings, doesn't show up here very well, they're actually orange. Industry standard is orange for one that can be used on PVC or ductile iron pipe. You can see the wedges on this are long, similar to a PVC wedge, but the teeth on it are a lot more aggressive, more like a ductile iron wedge on it. So it will work on both. These are available just in 4 to 12 inch. It's great to keep in stores or something on the shelf, so if you have a break, you can bring out an 8-inch one that can be used on anything, and you know you're good to go if you're not sure what your pipe material is that you're going out to fix. So wedges for ductile, small, aggressive. Wedges for PVC, a lot longer, cover most of the circumference of the pipe, not all that aggressive of a tooth. And then one that's used for both PVC and ductile It's going to be long, as I said, like the PVC, but aggressive tooth, so it bites into that ductile when needed to. Now these ones are going to have the washer on as well. So these ones, if you're using on a steel pipe, you're going to need to remove that washer. If you're using on an IPS PVC pipe, you're going to need to remove the washer. If you're using on ductile pipe or PVC pipe, you leave the washer on. Now I'll talk about serrated restraints. They're used quite a lot around here. Serrated restraints are another restraint that can be used on both ductile iron pipe and PVC pipe. Most common application for these, it's not the MJ fittings. Most common application for these is just a pipe-to-pipe restraint. So it's literally just that, just pipe-to-pipe. Here's my handy-dandy 3D printed restraint, goes on that side, and again, backup ring. This is actually a split backup ring, goes on that side, rod them together, and you've got everything you need there. There are two types of serrated restraints. There's bidirectional, which is this one. You can't see me pointing to it, so that was kind of pointless. Okay, the bidirectional one is the one on the left, and the unidirectional is the one on the right. People often ask, is one better than the other? My answer is no, they both do the same thing. We make both, actually. We make the bidirectional up to 12-inch. Most of what we sell is a unidirectional. We make that all the way up to 48-inch. But the people who only make bidirectional try to convince you that it's better because it doesn't matter which way you put it on. No one's going to screw it up, which is to a point true. But here's an example of an 8-inch restraint. Let me get that in frame. You can see that here is a big angle on there. This is a flat side. If the contractor tries to, and I had a bolt sitting around here somewhere, I don't know where it got to. There we are. If a contractor tries to tighten this bolt onto here, it won't tighten. You can't get your wrenches in there. You can't tighten it on this side. This side, it's flat. If a contractor puts these in backwards, I'd be more worried about what else they messed up on the job than just putting the restraint in wrong. That's the easiest thing to put in right. So having a concern of someone putting it in backwards, not really a concern. If you look at this, it also says nut side. Ours, everybody's, their unidirectional will say nut side on that side. So it's very straightforward. A lot of the times the unidirectional will have a higher pressure rating too. How the unidirectional ones came about and why we switched over is in 07, C900 modified, and the pressure ratings went up dramatically. A DR18 went from 150 PSI to 235 PSI because pressure ratings were, or safety factors were changed from 2.5 to 2.0 to get in line. It's a whole nother presentation. But, so you went from 150 to 235 PSI. In order to meet that, restraint manufacturers went through their designs and made sure that their existing designs could handle the new pressure ratings. Some people redesigned, us being one of them. We found this was a much better, much superior design, so this is the one we stick with. We still make the bidirectional because there's some municipalities that are dead set on that's what you have to have. So for those ones, we'll supply it, but generally you're going to get the unidirectional, and that's what most of the industry is now. And larger diameter, that's pretty much all you're going to get. 1200R, PVC up to 12-inch. I showed you for a MJ fitting, or no, for a PVC fitting, it again is just a backup ring goes on the fitting, and the PVC pipe will have the serrated one on that side. For larger than 12-inch, we have a 1200R, other people make different ones. If you're using a larger diameter fabricated fitting, you're going to have to find out who the joint restraint manufacturer you're using is and give them a call, because they're made to a specific diameter and they have a a range, but it's not a huge range they can handle. Every fabricated fitting manufacturer makes them different. I'll use DR18 again because it's the most common. If a fitting manufacturer is manufacturing a proper DR18 fabricated fitting, they will talk to the PVC pipe manufacturer, get thickened wall DR18 pipe so that when they expand it and get the bell, it has an actual DR18 bell thickness. And what that is OD divided by thickness equals 18. So the only way to do that is to use a DR18 thickened wall pipe, and then when you expand the bell, that's what it is. So if that's used, then the restraints will fit around that OD of that bell. If they use, the manufacturer uses a DR18 pipe, thickens the bell, that bell is now a thinner wall than a DR18 would equal, because the wall thickness on the pipe is that. You stretch it, thins out. Now the restraint may not grip it because it's a smaller diameter now. They can be made. They're made all the time, but you have to talk to each joint restraint manufacturer. Some manufacturers making the fittings actually use a DR25 pipe so that the wall thickness of the bell is thicker than a DR18, so they actually meet the standards that are out there. But then your OD is bigger. So when you're connecting to a fab fitting, give me a call, give the manufacturer of who you're using a call if it's not us, and just talk with them. There's also other tricks. I've gotten involved at the design phase with consultants and the fab fitting manufacturer, and we've modified the design of the fabricated fitting and the layout of the pipe bit so that we can use standard restraints, just a standard 1100, two serrated restraints, nothing special to order, makes it more affordable. But you need to start at the stage, work with the design engineer, work with the fitting manufacturer, and make sure you get what you want. Another issue that comes up is oftentimes they'll fiberglass a PVC fabricated fitting. If that's done, you have to make sure the fiberglass isn't in the location where the restraint's going to bite in, because then it won't bite in. It's designed to bite into PVC, not into fiberglass. So a bunch of things. Like I said, if you're dealing larger diameter fab fittings, call me or call the restraint manufacturer who you're using. Hopefully it's us, but that's the sales guy's job, not mine. If you're going to an MJ fitting, you can use a serrated restraint to go to an MJ fitting. I would never recommend it, but it is possible. I will show you how it's possible and why you will never ever want to do it. You've got your, we'll use this fitting. You've got your handy dandy fitting, you've got your gasket, and where did my piece of pipe go? There's my piece of pipe. And you've got your pipe. So unlike a wedge action restraint, a serrated restraint, it's flat on both sides. It's got nothing to compress the gasket. So the first thing you have to do is put on your gland. That gland compresses the gasket. To compress it, you use T-bolts. Put the T-bolts in all the holes, except for the ones that line up with the holes of this. For those, you need to use longer T-bolts. Put the longer T-bolts in there. Then you, normally this would be in 2 halves. I have it put together here just to make my life easier. Then you put your serrated gland or serrated restraint on there behind the gland, close enough that your longer T-bolt goes through there. Yeah, you can sort of see that, I imagine. And then you have to do up those bolts. So you have your T-bolts, you got to torque those down, torque the nuts on those longer T-bolts down to here, then put another nut on there. It's way more complicated and takes a lot more time than if you have this application. You're best off just go pick up standard wedge action restraint, put it on there, do up your T-bolts, tighten your wedges, boom, boom, done. So as I said, it's possible. It's not recommended. If you're going from PVC pipe to a push-on fitting, this is another one that I get questions on sometimes, and every manufacturer, again, in their literature states it somewhere. It's either in the writing, it's in a footnote, it's underneath pressure ratings. If you're going on to a push-on fitting, it's most common for 4 to 12 inch, 48 inch, you have no problems. You're rated to the pressure rating of the pipe. 48 inch. If you're in 10 or 12 inch, most push-on ductile iron fittings come with 2 ears. The 10 and 12 inch restraints, serrated, have 4 holes for the lugs to go through. Because there's only 2 ears on the push-on fitting, you can only use 2 rods. If you're only using 2 rods, you're using half the rods that the restraint was designed for, your pressure rating of that restraint is now cut in half. So your 235 PSI pipe to a push-on fitting with 2 rods into there is only rated to 110 PSI. Well, 115 plus or minus anyway. It's half the rating. So it's a very important thing to remember. 48 inch, you're okay. It's a 10 and 12 where it matters. Above 12 inch, most people go to an MJ fitting. It's very, very rare you're going to have a push-on ductile fitting above that size. It can be a push-on PVC fitting, which I just went over all that fabricated stuff. Call me if it's that, but coatings on these. Okay, actually, I should back up there for a second. I forgot to tell you all about the lovely colors of my serrated restraint. Where's a good picture of a serrated? There we go. Black. Now, black in a wedge action restraint, ductile iron. Red in a wedge action restraint, PVC. Black in a serrated restraint is for cast iron OD pipe, like a C900 or a standard ductile iron pipe. Green will be for an IPS size pipe or a steel pipe. So it's for the smaller diameter pipe. It'll be a green. Sometimes you'll have them come out as red. When you see a serrated restraint red, it doesn't mean it's for PVC. It means, and we do this, other manufacturers do it as well, it means it has a Starbond or an epoxy coating. Starbond is just our name for, it's a TGIC polyester coating. Does the same thing as an epoxy coating. It's just, we supply both. Different jurisdictions allow for both. EBA calls theirs Megabond, and it all depends where you're at, what you're going to be putting on. If you're going to be putting on a Starbonded epoxy or just your standard alkyl enamel. So your standard alkyl enamel on serrated is going to be black. If it's Starbond or epoxy on a serrated, it could be black, but likely it's going to be red, so you know that it's got that other coating on it. If you're using the Starbond or epoxy on the wedge action, it'll be black for the ductile, red for the PVC. We actually own manufacturing facilities in China and in the US, so ourselves, we can supply domestic or import restraints, or you can do blended. You can have the castings made domestically and the hardware made import, either China, India, wherever it comes from, or vice versa. Standard hardware is going to be your high-strength, low-alloy steel. That's, if you don't ask for anything else, that's what's coming. You can also get stainless steel if people are worried about corrosion, 304 or 316, or Star Blue. It's a blue coating. It's a fluoropolymer. It just goes on there. Generally, the blue-coated bolts are going to go with your epoxy or your Starbond coated fittings. Now I'm going to go through joint restraint calculator, just in case anyone wants to. I still got a 5. Okay, I'm going to go through this quick. Most manufacturers have this on their website. We've got it on ours. Other guys have it on theirs. Everything, the math behind it is all the same. Numbers might change slightly between whose you use because of rounding errors, but it's all going to be the same. So go to the website, click on there. Ours, you can choose imperial or metric, but once you choose it, it's for everything. And then you choose what material you're putting in. I can't read those ones. Select your soil types. There's a little information sheet, tells you what your soil types are. Safety factor, for joint restraints, safety factor standard 1.5 to 1. It's not a 2 to 1 like most other stuff. Whatever reason, it's always been, it's 1.5 to 1. That's your standard safety factor for joint restraints. Select your trench type. Again, click information, there's your trench types, generally type 5. Go to here, depth of bury. I chose imperial, so we're going 6 feet bury. CIOD, I'm saying it's PVC pipe, so we're going to select, what did I select, a DR41. You can select what type of bend, horizontal, vertical, offset, T, dead end. Select your size, 12-inch. Bend angle, we're going to go 90 degree, worst case scenario. And then you click Run Calculations, 17-foot restraint length if you're using, oops, let me back up. 12-foot restraint length if you're using bare ductile iron, 14-foot restraint length if you're using PVC, 17-foot restraint length if you're using poly-wrapped ductile iron. And it's just a matter of soil friction between the pipe and the stuff. So that's it. If you got questions, my contact information's there. As long as it's not on pricing, it's a technical question, I can answer it. If you've got availability questions or pricing or anything like that, call Craig Sloan. He's a local sales guy for Western Canada here. He's actually based out of Chilliwack, so he's not too far away. And there's his contact info as well. So that's it for this presentation. Hope you guys liked it. And if there's questions, I can answer them or email me later and I'll get answers to you. Okay. Yeah, so restraints are always manufactured for the outside diameter of the pipe. PVC pipe is an OD controlled pipe, so your cast iron OD. So yeah, it's an OD controlled manufacturing for it. Okay.
Okay, well, thanks so much, Jeff. Appreciate that. That's the end of session 1 for WaterStream Day 2. We're going to take a 15-20 minute break, and we'll be right back. Thank you.